Okay, this is DTC, also known as double tune circuit. This is part of some of the software from the book Experimental Methods in Radio Frequency Design, which was done by Wes Hayward, Rick Campbell, and Bob Larkin. It's a ARRL book out somewhere around 2006 time frame, as I recall. So let's make some modifications here. We'll make a 20-meter bandpass filter. So we'll set the frequency. We can set our resonator inductor values. Let's change this to just a microhenry. Let's be maybe conservative on the Q and bring it in at about 150 for unloaded Q of the resonators. The software assumes ideal capacitors. And let's begin calculation. Again, we can set the end section loading. So in this case, it'll be a filter intended to be in a 50 ohm environment. The two numbers that come up right now is the nodal capacitance right here, which represents the total capacitance at the junction, essentially across the inductor to define the entire resonator. Also, the minimum series end capacitance is a value that we can modify later by adding extra capacitance in. But if we just finish the design with the minimum, we'll get essentially zero capacitance shunt on the ends. More capacitance, shunt capacitance on the ends allows us to have better flexibility on the choice between the end section loading cap and the shunt cap. And if we choose bandwidth appropriately, we can influence the value of the coupling cap. Now in this case, it's a pretty small cap, 1.56 puff. That's not a whole lot. That could just be some small pieces of wire twisted together to get about 1.5 picofarads, and you know, maybe 2 picofarads would be about the most we'd want to go there. But we can come back here and let's make this be significantly wider than the 20-meter band. And maybe if we pick something like 752 kilohertz, which I already investigated earlier, we can see that the end section capacitance changed. But when we finish the design, we've got a 4.7 picofarad coupling cap. And this is a much nicer standard value, and this allows us to push the 3 dB down points out past the band edges. And for some applications, one might want to bring them in a bit closer just for image rejection improvement. But for casual receivers, this would be fine, and this would also be just fine for most transmit mix bandpass filters. So at this point, we can simply save it and open it up later in GPLA. And we are saved. And now we'll open up GPLA and look at the frequency response.